Questions? Everybody has homework done. This is Steve Sunday. All right, go ahead and hand in your attendance. Ask this question. All right. So we're on quantification, and since there are no questions, the idea that if we have any sort of function of unknowns or many unknowns, we could have one, we could have however many, where we're talking about a object has property predicate, right? The idea here is we have things that go in and they're coming out of a particular location. We had our domain, our universe of discourse. The test of does it have the predicate is always the question. And then out will come a true or false, and every object in here is an element of the universe of discourse. And so we just test it and it'll spit out true and false. And so we talked about this process of becoming true or false, the three ways that we would go through here, and the process of finding if true, false, again, is called binding. And the three binding ways that we have was 1, evaluate, and 2 was universal quantification, and 3 was existential. Quantification. And when true and when false can be kind of visualized in a way. We could simply say things like, for all x, so if this here, if we're using, say, f, something has a predicate property, whatever you're talking about, mark, high, blue, whatever you want, as you're going through this particular thing. As we test it, this variable is not, if that's an x, it's not really an x, right? It's a replacement location. It says whatever goes here is what goes here. It's the idea of a replacement. On the other hand, once we do a binding, say with a universal, if I would say for all e, f of e, that is the binding. For all elements in the entire universe of discourse is what we're doing, right? So what we've done is that E now does not represent a element. It represents, with this notation, wherever I see an E on this side, in there, that E represents everything. Everything in the entire universe of discourse. So it actually has meaning. And the binding tells us, again, for all or a existential is going through here and saying, all right, how does this work? And so if we were going to do true and false, the idea here is when is it true? Is if everything that you did here between true and false, everything, no matter what you did, would simply map to true. That's when it's true. Everybody goes to true. On the other hand, when would it be false? Well, if this is true or false, even if I would have a lot of things going over here to true, that there would be a possibility of one going to false, right? And then this guy here would be my counterexample. At least one goes to false, right? If we visualize it, everybody gets mapped to true, it's true. But well, if some goes to false, well then what you said was wrong. Because you told me everyone. If we have the existential binding, there exists some S such that f of S, right? Again, when you see this, what does this S represent? Because it's bound S. It says something on the left. It doesn't tell me which. It tells me something, one or more on the left, has gone to true. So to me, it really wouldn't, when we would have this one, if we would have all of these elements and we would have true and false, it really does not matter that we would have, say, a bunch of things going to false, right? These all go to false. But on the other hand, if I have one or possibly more go to true, right? That's when this would be true. Okay, at least something goes to true. And then those some things is what the S was talking about. Okay, when would this be false? When everybody simply goes to false, right? Everything goes to false. Well, you said somebody is, but everybody went to false, so that's just not going to work. Does that visualization sometimes help? All right. So that's how we bind these things up in terms of either we evaluate it, evaluation. Every one of those arrows is an evaluation, right? The arrow, one arrow itself is this element went here. That's an evaluation. All says I want to talk about everybody in the space. Some says somebody. I don't care one or more, but I don't have to. I don't even have to know who they are. I just have to know they exist. And we'll actually do arguments in this class where I can say that something exists, but I can't tell you who it is. We'll actually show that something exists that has a particular property. It's either person 1 or person 2. If it's person 1, it's not 2. If it's 2, it's not 1. Well, who is it? I don't know. But I know he at least exists. So we'll do proofs like that. We won't find it, but we'll say, it's somewhere over there, and we'll prove that it's somewhere over there. So sometimes existential proofs are you just literally find it. Sometimes you just show that, well, it's somewhere. It meets these things. One of the things that happens on binding is the idea of what's called scope. All right, scope and symbol selection becomes important. And so sometimes it's no question if I pick right things. So if I would say things like L, let's go ahead and stick with it, a nice square, triangle, denotes, triangle likes to eat whatever goes into the square, right? Obviously, there's a natural universe of discourse here. Triangle, we might pick people because they can like, or we can pick, let's say we're talking about pets. So triangle is a pet, and square is food or animals. Let's say this was animals and other animals, right? So we eventually make a niche overlap graph where you have things like that animal eats this animal or they share a particular food source. Right, so we can do things like that, but when we would do a binding in a particular way, one of the questions that sometimes happens would be if I would compare things like for all x, L of x, dog implies there exists an x, L of peanut butter comma, x. This gets really awkward if in your upper notation you have x's and y's. And so we look at this and ask, okay, what's going on if we would have this particular thing? The idea of scope is who does the evaluation and who does the binding actually work with, right? So if I would have this problem here, like this x and say that x, one of the ideas of scope is, are they the same thing or are they different things, or is this a completely different problem, or what's going on, right? Now, if I would have just given you this, you would know who the x is, right? You would see x is in the first position of L. Now go up to my function. Who's in the first position of L? Things that get eaten. So x is a thing that's getting eaten, but x has been what? Bound. Bound to what? All. So this all x says that we're, okay, from this point on, whenever I see an x, it's in all of the universe of discourse. But which universe of discourse? Well, since the x is in the position of being eaten, if it's food, right, it's all food. So these two things together are saying that this x means all food. Why? Because it's position in the L in the binding of the x. But if I would have given you this problem, what's the position of that x? It's in the position of the triangle, and triangle is the animal stuff, right? And so that x has been bound to who? Some, right? And so when we look at this x means some animal. Are they very different from each other? Yes. But did I use the same variable? Yes. Right? The idea of scope is how far does this binding go? Sometimes it's easy. For example, how far does the binding of dog go? It's inside of L. It's bound right there on the left-hand side. It has absolutely nothing to do. There is no dog at all on the other side of that arrow. Right? It doesn't flow over to talk about dogs. If you put this into words, what does this say? If you do it the long way. If, because this is an implication, if, what's the left-hand side? So this particular dog, right? If, for all foods, right, a dog likes to eat their foods, right? So if a dog likes to eat all foods, then, what's the right-hand side? There's some animal that likes to eat peanut butter. Now, does that entire sentence make sense? No, we're just playing, right? So,
is it safe to assume that when you see the universal existential quantifiers that there may be a scope change that you have to look at?
Right, and that's what we'll get to. We'll talk about null quantification and other issues. And like sometimes you could look at this and say, all right, the idea of scope is how far does this go? And this actually works on order of operations and parentheses, right? It would just say this only applies to the L. It does not go across to the other side. And so the idea of scope for here, this for all x, because of parentheses, this here is the scope. This here is the scope. If we want to go past that, I need to parenthesize it so that I know it gets outside of it. We can get some scopes going on. Now, sometimes you can kind of play around with the scope, even though this is where things get really weird. Since these were different scopes, the smarter way to do this problem would be to use a different variable. Because it looks like when you're using the same variable that you meant x, and that's x, and you're talking about the same scope, but I'm not talking about the same scope. This x in here has been bound to all foods. That x over there has been bound to some animal. And so normally what you would do is say, that causes confusion. If you go to a new scope, pick a new variable. And a better way of writing this that would, look at it, say better notation, would be say, okay, what was my first notation binding? All what? All food. So I probably should have done this. For all foods, LF dog, and then implies, what's the other one talking about? Some what? Animal. So there exists some A, let's use A for animal, L, there exists some A, L of peanut butter, A. And it reads a little better. Because there were different scopes, there are different universes of discourse. Go ahead and pick different variables. The book picks some pretty bad notation. So here's the book. Here's a book example. Let's say L of XY denotes X loves Y, and they would do something like this. For all X, L of Mark, comma, X, imply, and there exists a X, L of X, comma, cheese. They use the same variable too often. You sit there and look at it and say, oh, I see some X's, but I see some X's. I bet those X's are those X's, and the answer is no. Up here, the X's and Y's are not X's and Y's. They're positions. They're things waiting to love and things waiting to be loved. If you're in the first position, you're doing the loving. If you're in the second position, you're being loved by according to the X, comma, Y, and then how you read out the sentence. Sometimes it can be flipped, right? And here, this X is not the X above. What is the X in this scope? Things that are being loved, right? And so I have bound to all things that could possibly be loved. So wherever I see X in this scope, X is all things that can be loved, right? What about this scope? X is something that can love, right? Why do I know that? By its position in binding. So you have to be careful. It's one of the bad things about using X's and Y's for everything, and PQs and R's for everything. Pick different variables that make a little bit more sense. So does everybody say, well, like this notation, does it make sense compared to you, but it allows you to see, okay, I could have picked a little bit different way of doing it, but understand that the book can sometimes lead you astray if you get too focused on what these things are. All right. Now one of the other questions of scope is what happens if you kind of get confused a little bit on these. Things that are not. Okay. Example of not equivalent. For example, for all x, p of x, or for all x, q of x, is not the same as for all x, p of x, or q of x. Anybody give me a reason why? When would the first one be true? So we have predicate P and we have predicate Q.
No, the first one would be either all of P is Q or all of Q is true. The other one is P and or Q would have to be true for that. That is just, so if P is false, then Q could be true and it would still be true. But with the other one, it has to be all one or all.
I'm circling the scopes, right? We circle the scopes. So that or would be true or true, all right, true or false, false or true, true or true. It would be true, right? The other one would be, well, there's one scope. So for the x's on the left, are they the same x's? No. So again, imagine a bucket. For everything in your bucket, it's P. Or for everything in your bucket, it's Q. Or both. Right? And so the left would be true is if I would have a bucket of, let's say P, well, let's say it's red cubes and blue cubes. If everything in my bucket's red, or everything in my bucket's blue, or if everything in my bucket is red and blue, right? Because it'd be red, like two colors. But on the right-hand side, what does that say?
It's essentially evaluating every element at the same time instead of evaluating them individually.
Well, no, they both would still evaluate individually. But the left-hand side, it looks at the bucket once, puts it back down, picks the bucket back up, and then checks the entire bucket for Q. What's the other one? Pick it up once, and then look at the bucket. Is everything in the bucket either a red square or a blue square? Right, so it would allow a mixture of the two, right? And those are not the same thing. One's asking for, is it all red? Is it all blue? Or are the objects somehow both red and blue at the same time? And the other side says, every object is either a red object or a blue object. And I could imagine it's just a simple fully red, fully blue, all mixed together. And it only looks at it once. So it's one that looks, on the other hand, we could do the same sort of question with existential. Those are not the same. What if I had there exists an x, p of x, and there exists an x, q of x? Well, this is not the same as there exists an x, that is p of x and q of x. Okay, let's talk about red and blue. The left-hand side, what's the scope? There's two completely different scope questions. On the right-hand side, there's one scope question. Grab the bucket. What's this first one? There's some red cube in it. And what does this next one ask? Some blue cube. So the left would be true if I could find a red and a blue in it. What's the right looking for? I look at it, and there has to be something that is both, one object, is both red and blue at the same time. One or more. Those are not the same question. You can imagine one is, did I find a red one, put it back down, and did I find a blue one? Yes. And the other one is, do I find one or more that is both red and blue at the same time? Completely different question. And this is also a good example of picking different variables. Right? You look at this and say, well, this is x. That x is not that x. Right? On the left-hand side, these x's are not the same x's. They're different bindings. And they're different scopes. So we have to be careful. Now, on the other hand, we have what's called null quantification, which is, well, what if one of the things that you're looking at, let's say there's two objects, one has an unknown variable like x, but the other one doesn't have an x. It's just a statement, like my name is Mark. So what if I mix propositional functions with propositions? That's the idea of null quantification. The null part says it's not a propositional function. So what if I would have things like, okay, for everything it has a predicate, then, whoops, not then, or I have some sort of compound proposition. It's not a variable, just a proposition, some sort of sentence. One of the things that we like to do would be to say, well, do I have to leave the for all just on the thing that it's its scope? Could I somehow suck the A into the scope? And the answer is, for this problem is, yeah, that works. This would be the same thing as the for all x, that you either have the propositional function or you have the statement. A has no x. So it's okay to, when we look at it, we have one scope on the left, but we have one scope on the right, but it's a bigger scope. It's fine because A doesn't have a variable in it. So it works. This also works for and. This also works for there exists something that is a proposition, or we have, sorry, there exists something for a propositional function, or we have the statement, that's the same thing as there exists, and go ahead and group that in and just simply say that, well, what if we have the propositional function or we have the thing? This is also true for and. So null quantification allows you to say things like, everyone in your bucket has this property, or my name is Mark. It's the same thing as saying, for everything in the bucket, just take them one, pick one out for every one of these. It's either blue or my name's Mark. Next one, it's either blue or my name's Mark. Really, what am I using? I'm using idempotent, right? I'm going to say my name is Mark all the time. So just you could. This is to say it once, and that's to say it a bunch of times. Once for everything that you took out, and it's the same for the existential. Now, does the order matter? Could I say the thing and then the binding? In other words, if I flip the A and then the for all, flip the A or the all. Is or and commutative? Yes. So it doesn't matter the order. All right. So I could flip those around and it wouldn't cause any problem, but we do have an operator that is not commutative. So what would happen for all x? And I had A implies P of x. And then I would do, say, for all x, and then P of x implies A. Let's take that and then try to get rid of the null part. This is logically the same thing as A implies for all x P of x. All right. What is the disjunctive form of implication? Not left or right. What's not all? Some. So this would actually be for some x, P of x implies A. So we could take that thing and say things like, okay, what if I said, for everything in the bucket, if my name is Mark, then the object's blue. That's the same thing as saying, if my name is Mark, then everybody in the bucket's blue. Those are the same sentence. But on the other hand, if I say, for everything in the bucket, if it's blue, then my name's Mark. Here's a head scratcher. It's the same thing as saying that if something in the bucket's blue, then my name's Mark. And you ask, okay, is that the same to you? For everything in the bucket, if it's blue, then my name is Mark. Okay, why can't I just simply go to a sum? Because, well, if it's not blue, it's vacuously true. So as long as there's some blue thing, then my name is Mark. Because the others would be just vacuous. So that's why that flipping is okay. The same is going to have for the existential. Similarly, I could put an existential on both of these, and you would flip it, accordingly. If it's an existential on the left, that would be existential, but that would be existential, that would be existential, but that would be universal. Same problem. So we can, as long as you don't have anything of this variable, you can start to move it in and out of the scope. But for ors and ands, just do it. Implies, be careful. If the propositional function's on the right, you're fine. But if the propositional function's on the left, it switches. Is everybody okay with how the English words change on these things? All right. Now, if you're looking in the book and you ask, where's null quantification? Where are these things that are not logically equivalent? That's actually just simply this definition. This is where the book starts to take. I said they'll introduce things that it'll later use in the homework. So that means when you read the book, don't just simply read the section. Go ahead and read the homework. If you start to see things in the homework that are bold font, it probably has little things. This is a definition that we might want to know. And each of these are actually, each of the null quantifiers, they go through, make the argument and show that these are actually logically equivalent. Convince yourself. But it's in the homework, it's not in the section. So we always have to be careful to make sure that you're reading and trying to do more than just what's, just lightly looking over it. All right. Nested quantifiers. What happens if I have a bunch of them? So for 1.5, nested quantifiers is, all right, if I have something like, say, L of square, triangle, and circle denotes that square loves triangle topped with circle. All right, what would be a natural universe of discourse? Here's a good notation. Pick some unusual variables, but also the order that you read it in the propositional function, normally keep that order on the left. Because it's like that first one I didn't do, I flipped it, but I did it purposely to make you think hard. Normally when you do it, if it shows up left or right, show it left or right. It makes it easier to think about. So what is square normally coming from? What's square doing? Loving things. All right. What are triangles? Things that can be topped and loved. Okay. And what's a circle? Things that can top things. All right. So if you had to make a guess, what do you think I'm talking about? Like desserts, right? And square would probably be people. So if I had universe of discourse, kind of a natural thing, the universe of discourse square is people. The universe of discourse of triangles, make it is ice cream, just because that's the greatest thing ever. Not really, but. And the universe of discourse of circle is ice cream toppings. Vanilla ice cream with crunchy peanut butter. That's really good. If you haven't had it, try that. All right. So this here is what we're talking about. Now, if I want to turn this into a proposition, I have to do binding. But the problem is, so far all of our bindings has used one quantifier, and then the others, if I had more, I would just simply bind it to mark and vanilla and peanut butter, right? What we did is just do one at a time. Now the question is, what happens if I would do things like, what does, let's make it for all, let's make it there exists. There exists an I such that for all T, L, mark, I, T. Okay, the entire scope is just on this L. I don't have any other operators. Okay, what is I being bound to? Some ice cream, that's why I used an I. All right, what is T being bound to? All toppings. And what was the square bound to? Mark. All right, so how would I read that?
There is some ice cream such that Mark likes with top with everything.
Right. Such it'd be like, there's some ice cream such that for all toppings, Mark's going to love it. That's, I don't care what you top it with, I'm going to like it. But be careful, I want real ice cream toppings. No dirt. All right? So there's some ice cream that I don't care what you top it with, I'm going to love it. That's what that says. Okay, one of the questions now will be, does order matter? Do you think this changes up if we start to play around with the order? So there is some ice cream that can be topped with anything, and Mark will love it. right?
Now, where was the mark in that question? Like, how did you get? Oh, it's L mark. Oh, it is L. Okay.
There's the L, and there's mark, right?
All right.
So that's my L. Okay. Now comes another question. Does order matter? For example, what if I would do for all t, there exists I, L, mark, I, t. What does that say?
For all toppings, there exists an ice cream that Mark will love it.
Right. And so one of the ways to think about this is to think about this in terms of a spreadsheet. We have ice creams and we have toppings. What does that first one say? There's some ice cream, think of row, such that for all the toppings on it, Mark will love it. What does the second one say? For all the toppings, there exists maybe different ice creams, right? There exists an ice cream for every one of those toppings that Mark will love those things. Is everybody okay with that? So one could be it's just one ice cream with any topping, I'm going to like it. The other one is every topping could have its own specific ice cream that combination is what I like. Are those the same thing? No, right? Wait, I might as well say it would be every topping has an ice cream such that Mark loves the combo. Everybody okay with the idea? And I can obviously say not the same. So guess what? Order matters. But that's not necessarily always true. If we would make this thing into a table, we have the following. For order. If I have for all ice creams, for all toppings, and let's just say get rid of the mark, that's just Mark, and I say love, and I'm talking about Mark loves, right? L is Mark loves this. IT is going to be the same as for all T, for all ice cream, LIT, right? Just assume Mark's always here, right? So what is this saying? If I think of this as a spreadsheet, for all the ice creams and all the toppings, the entire thing is a big bunch of truths. Well, what if I would look for across the toppings and then down all the ice creams? Would I find if the entire thing is all truths, is it still going to be all truths? Yes. So that's fine. What if I would say there exists an ice cream that has a topping that Mark loves that combo? Well, if there's one or more ice cream topping combo, if I first pick the ice cream and then the topping, would I have found the same combo, because that's the one I like? If I would rather said, as I went through the line, I told them the topping and then I told them the ice cream, would I tell them the same thing? I like vanilla with peanut butter. If I did this, vanilla, peanut butter, I like that. Or I went the other way, peanut butter, vanilla. If I said the topping, then the ice cream, would I still get vanilla ice cream topped with peanut butter? And I love that, yes. So that's okay. The problem is mixed. For all ice creams, there exists a topping such that I love it. That is not the same thing as, whoops, which one did I say there exists?
Topping.
I said the toppings. For all ice creams, there exists a topping such that I like that combo. That is not the same thing as for some topping on all ice creams is good. What does one say? All ice creams have some topping associated with it that I like. The other one is, there's a topping, right, that I don't care what you put it on, I like everything. And also the other way. there exists an I for all t, L of it is not the same thing as for all t, there exists an I, L of it. Is everybody okay with that? So if you mix the quantifications, order matters. If you have the same quantification, order does not matter. So we're okay, why and when. All right, what is this? What is this here? Put that in English.
There exists an ice cream such that for any topping.
Okay. What is, so there, some ice cream can have any topping and I like it. What does this say? All toppings have an ice cream that goes good with it. Right? Different thing. Now on the other hand, if one is true, is the other true? If it's true that there's a special ice cream such that for all toppings it works, is it also true that for all toppings they have an ice cream? Yeah, that one. So if one is true, it implies the other one, right? It's actually tighter than the other one. But the other one could be true with the other, but this one could not. Everybody has their own special ice cream.
That'd be kind of like saying their truth values are both true,
The left
but
one
they
looks
get two
like,
different ways.
if I look at this as a spreadsheet where this is ice creams and this is, if this is ice creams and this is toppings, this one would be true, 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 right? There exists an ice cream such as that's, I have a row of truths. What is this top one asking? This top one is asking that everybody has a true somewhere in its column, right? Somewhere in its column there is a topping ice cream combo. For all toppings they have an ice cream. But on the other hand, the right hand side says every column has a true in it. Does every column have a true in it? Here, does every column have a true in it? Yes, right on the left. But they aren't the same thing. The left would be a special case of the right. They're not identical. So there's some crossovers, and we just got to think, okay, when is this true? What's going on? Spreadsheet's a good way to think about this. As we get to triple, it gets more difficult because then it'd be like a cube. Like, toppings here, people. Okay, four-dimensional, it gets more complicated. But we need to be able to do those little bits of discussions. All right, and now I can talk about, again, negation. Negation's nice because it doesn't matter how you mix it. If I would say it's not true that there exists a person such that for all ice cream there exists a topping that the people ice cream topping. So what is this saying? This is saying that it's not the case that, it's not true that there's some person out there such that for all ice creams there is a topping that person, that one or more persons that I was talking about loves those combos, right? I'm saying that's not true. Is everybody okay with what that inside parenthesis states? There's some special person in the world that loves all ice creams with some particular topping. Every ice cream has a topping, and put those two together, they're going to like it. On the other hand, if I say that's not true, the negation would go through and flip everybody. For all people, there exists an ice cream such that for all toppings, they do not love it. I negate the predicate. Well, if it's not true that somebody likes all ice cream with something, it says, well, that means everybody, for everybody that you checked on the entire planet, there was some ice cream, and I don't care what topping you put on it, they didn't like it. Jalapeno ice cream, I don't care what you put on it, not going to like it. Everybody okay with that? And so negation does like exactly what you would expect. Now on the other hand, the question is, do you go through once, do you go through the second quantifier, do you go through all quantifiers? It really kind of gets down to which one verbally makes a sentence that works for you. Right? I could have negated edit stopped at any time, right? On the left, right after, I could have moved it here, I could have moved it here, I did move it there. Because why would you pick one over the other? Well, which one sounds good to you or makes sense in your head? It's usually what we're going to be working with. For example, maybe you want to go the other way. You would said, for everybody, there is some ice cream that it's not true that there exists a topping. Maybe that makes more sense. For everybody out there, right, there's some ice cream, I don't care, it's not true that you can top it with something, and they'll like it. Maybe that makes more sense to you. Maybe you want to go the other way. Stop early. Everybody, it's not true that for all ice cream there's some topping that they're going to love. The combo. Maybe you want to say it that way. They're all the same. Normally, in terms of simplification, you usually try to put the negation on the predicate. You want to take it in until, say, they don't love. One of the odd things here of problems of this nature is human language. What does it mean to not love something? You don't love it. A lot of people say, well, the opposite of love is hate. And it's like, well, let's get into philosophy arguments, right? It's like it gets down to, if there's any questions, you need to define it better. I would say the opposite of love is ambivalence. It's like, I don't care. I don't care about you. Hate, at least you have emotion. One of the other things that are useful, and one of the reasons why I pick odds, is the idea of kind of going forwards and backwards in problems and trying to say, okay, what if we would have, say, a problem like 5, and they have that, let's say here, let's say they do a W, and they have that W denotes, I'll use their notation because they like to use X's and Y's, which makes things harder. Student X visited website Y. And the natural universe of discourse is students and websites. And what would this look like? There exists a Y for all Z such that Y does not equal David, and parenthesis W David, comma Z implies W Y Z parenthesis. All right, that's the book's notation. Life would have been a lot better. All right, for the first one, X is not an X. What's X? A student. Y is not a Y. Y is actually a website. Here, Y has been bound. What has Y been bound to? Where's Y? It's in a student position. Since Y is in the student position, that Y, in terms of binding, says there is some student because he's in the student position. What has Z been bound to? So wherever I see a Z, so the Y means some student. That means some student. Z has been bound to who? All sites, right? So wherever I see a Z, why? Because it's in the site position. That's all sites. That is all sites. All right, life would have been better if they would have did this. So there's no confusion. And probably that. there's some student such that for all websites at all, the student's not David. So I'm not talking about David. I'm talking about someone other than David. So this is somebody not David. And not only is that true, what does that right-hand side say? What does this say? What's the W David, comma Z? Okay. For all sites, this is an implication. If David has visited that site, well, what if he hasn't visited the site? It's vacuously true. So what am I focusing on? Sites David has visited, then what happens? Then Y, it's necessary that Y has visited Z, but with the if condition, it's actually, what does Z represent under this if condition? Sites David has visited. Does that make sense? Because it's an if-then. If David has visited it, because, well, for all sites, what if David hasn't visited? Then it's false implied, so I don't care. This is only true. This evaluates to true when David visited the site. Then it's necessary for what? Y to visit the site. So what does it say? And I want to shorten that. There exist some students such that for every possible website, the student's not David. If David has visited a website, then that student has visited the same website. Shorten that. Somebody's visited the exact same websites as David. And sometimes you might say it this way. Someone, not David, has visited the same sites, I might as well say all the same sites as David. Now, a lot of times you could leave off the not David, because I mean, most people would say, I know what you meant. When you tell me somebody's visited all the same sites as David has, you'd say, well, that's true if it's just David. He's like, don't be stupid. You know what I meant. You know I meant not David. But if a person says, they drop that on you, fine. Someone not David has visited the same sites as David. Is everybody okay with that? And so one of the things that you want to do, like what's called reverse reasoning, look to the back of the book and see, they'll give you a nice condensed answer and say, ooh, how did they get to that from that, and try to work towards each other, and it might make your life easier. All right, that's it. Sorry I went long. Next class, sorry. Attendance next is back to 1.4, 33 A, B, C. All right, that's it.